Lecture is visible now.
Yes, sir.
Yes, sir.
Bismillah ar-Rahman Rahim. So today's topic is one from the processing and recovery element, which is the functional element of solid waste management system. And we have covered all previous four functional elements, including waste generation, storage, collection, transfer, and transport. And this is the last part of processing and recovery. The first two parts were processing techniques for plastic waste recycling and organic waste recycling. And then particularly we had two techniques which are very feasible for the domestic waste management. Like composting has been discussed in previous lectures, and now we are going to discuss the biogas generation or the processes involved for the biogas generation. Meanwhile, there would be the last functional element in coming week, which is the disposal of the solid waste. So all these things will conclude the waste management subject. As far as biogas is concerned, we can see in this picture that one person is feeding at the left side of the biodigester. One person is feeding the digester, and this digester is offering anaerobic conditions. And these anaerobic conditions would be leading to the generation of the biogas after a certain time period with a specific favorable set of conditions. And later on, this gas can be collected through a system, and then it can be utilized in different community level needs. And the rest of the waste, which is called as biofertilizer, because it has been stabilized after the decomposition of the initial feed stream. And the stabilized material is left over, and that stabilized material can be utilized as manure, as we can see at the right side of the picture, that a person is using this slurry, or this maybe this biofertilizer um, for the horticultural activities. So from left, the cow dung is being generated by the livestock, and then it is being utilized by the person who is putting the feed into the biogas generation unit. And then after the generation of the biogas, and after a certain time period, there are two products. One is solid biofertilizer or semi-solid material, which can be utilized as biofertilizer, and the other one is the biogas. And the biogas is dominant with CH4 and CO2. So both the products are useful. Initially, we had waste, and now it has been converted by the use of this technique into two useful products. One is the biogas, which can be utilized for various domestic purposes, like it can be utilized in heating up the homes, it can be utilized to lighten up the homes, it can be utilized to cook the food. And the other product which came from this unit was a slurry or semi-solid type material, which is a stabilized material and can be utilized as biofertilizer for the horticultural activities. Can someone elaborate what exactly is this picture? What do you see in this picture? What is this?
Ji sir, I think it is a satellite image extracted through GIS.
Yes, exactly. You are right. This is a satellite image and captured through a satellite, and it's a night image.
Okay, sir.
And it is elaborating, it is depicting that how much part of the world is lighten up at that specific time period when it was taken. And we can imagine that how much energy is needed for the entire globe to lighten up different utilities, commercial areas, and household levels. So there is a lot of need of energy, and this energy is being more or less it is being met up by the burning of fossil fuels. So we can imagine, we can estimate the impact of the burning of the fossil fuels in our atmosphere and the relevant phenomena like global warming and climate change. So um, uh, there is a huge requirement to investigate, to study, to conduct studies, and to design the experiments for the alternative in terms of various energy generation of energy, and it is incorporating into the energy which had to be taken from the plants which are burning the fossil fuels. If it is being replaced, then it means that we are reducing the burning of the fossil fuels. That's why we can see a huge opportunity in terms of generation of the alternatives, and biogas is one of the alternatives to generate the energy. So it's very important to keep life running, and life is like uh, totally demanding, and it demands a lot of utilities. And if we keep on using our natural resources as it is, then we would be like using those extravagantly, and our next generation would be compromised, and they won't be able to enjoy the same quality and same quantity of the resources. And ultimately, the life would be impacted, and there will be a huge threat to the humanity. So we have to adopt the sustainable development mechanism, and sustainable development mechanism ensures that we must keep an eye on the future generations so that we can avoid using the resources extravagantly, and we can think of the upcoming generation, and we can use the natural resources wisely. And if we start looking for the alternatives and we go for the renewable energy sources, then obviously the natural resources which are limited, that is the fossil fuels, would be lasting for a longer time period as compared to the current situation of their utilization. So without energy, there is no life. And if you look at the energy consumption, it is increasing on every passing day. For example, if you look at this trend, it shows that in 90s, basically the graph is showing the mix of energy. The green patch shows the renewable energy, then blue patch shows the nuclear energy sources, then gas and oil are see that there is a very minute quantity of renewable energy and nuclear energy, and the rest of the energy mixes are natural gas, oil, and coal, and all of these three components are having a lot of participation or contribution or the percentage in terms of the energy utilization. That is 90% of energy. The fossil fuel energy coming from the fossil fuel, and the uh, y-axis is showing the millions of tons being utilized in terms of the energy, and x-axis it shows the timeline. With the passage of time, increase. Are you listening me?
सर आपकी आवाज नहीं आ रही सही से।
सर आपकी आवाज चली गई थी बीच में।
कहाँ पे हम डिस्कनेक्ट हुए हैं, कहाँ से?
सर वाई एक्सिस से आप बता रहे थे, इसके बाद
किसका?
सर ग्राफ के वाई एक्सिस के बाद से।
ऑल राइट। अगर कुछ ऐसा होता है तो काइंडली आप मुझे टेक्स्ट कर दिया करें, बिकॉज इफ द मीटिंग इज डिस्कनेक्टेड तो आपके बोलने से भी मुझे तो नहीं पता चलेगा ना। सो इफ समथिंग हैपेंस तो उमेश यू कैन ड्रॉप अ टेक्स्ट टू मी। आई वाज सेइंग कि आपके वाई एक्सिस पे जो क्वांटिटी है एनर्जी की, दैट इज बीइंग रिप्रेजेंटेड, एंड एक्स एक्सिस पे टाइमलाइन है। विद द पैसेज ऑफ टाइम the demand of energy is increasing, and with that increase we don't see a significant contribution by the renewable energy or maybe nuclear energy. We are like witnessing that the fossil fuel energy, that is coal, oil, and natural gas, is being utilized on an increasing pattern, and it's obviously not a sustainable development approach. It's just to meet their own needs, and no one is going to consider the future generation. So we have to consider this graph as an opportunity, and we can consider it as a Pareto chart as well. There is a lot of opportunity to cut down the basic fossil fuel energy sources and to introduce the renewable energy sources into our energy mix. So there is a lot of opportunity of introducing the renewable energy in your system, and biogas is one of the renewable energy sources, and there is a lot of waste being dumped unnecessarily, and we can consider that waste as our resource. That's not a waste, but a resource, and it can offer a lot of energy generation, and that energy generation can be like can be replaced by the fossil fuel and can replace the fossil fuel energy. And if the fossil fuel energy is replaced, तो हमारा जो total energy consumption है fossil fuel का, that would be reduced, and our curve for renewable energy would be showing maximum quantity in terms of the generation of the renewable energy. हम waste management subject पढ़ रहे हैं. That's why we are talking about the biogas generation. But apart from the biogas, we can have wind energy, we can have solar energy, we can have biomass energy, which is incorporating biogas as well, and then geothermal energy, tidal energy. There are various renewable energy sources, but the prominent concern for this subject is biogas generation, which is a source of renewable energy. So we have a lot of demand and huge opportunity to introduce the production of biogas generation, and this would not only reduce the waste, but it would be eliminating the greenhouse gas emissions to the atmosphere, and it would be putting an extra advantage of eliminating the fossil fuel energy consumption and introducing the renewable energy system, which is a green energy input to our energy mix. And similarly, it would be benefiting the future generations in terms of enjoying the same quality and quantity of the life with the same quality and quantity of the natural resources. So, if we look at the energy scenario in Pakistan, the per capita energy consumption is one of the indicator of industrial development and quality of life of a country. The per capita energy consumption calculation shows the quality of life in a country, and it also shows the industrial development of a country. It's an indicator. Basically, uh, as much as energy per capita is available for a country, that country is considered with uh, much better quality of life and a faster industrial development. Pakistan is the poorest of the poor as far as energy consumption per capita is concerned. We are not offering a lot of energy to per capita consumption. Pakistan has 14 million BTUs as compared to 92 million BTUs of Malaysia and 32 million BTUs for China. 34. So it can vary. The statistics obviously are increasing on daily basis or maybe on annual basis for China and Malaysia, and ours are decreasing. So it cannot be 14 million exactly, but it might have lower down now. And per capita electrical consumption in an year for Pakistan is 470 kilowatt hour. Like you and every other person is using 470 kilowatt per hour on annual basis, kilowatt hour on annual basis. And in contrast, the Malaysian person is using 2708, while a person sitting in Singapore is using 6775 kilowatt hours on annual basis. You can see the difference between all three countries. Singapore is an advanced industrial country with less population. That's why the average is higher, but still they are offering a lot of energy to their residents. Then Malaysia with sufficient population, with a huge population, and even then uh, offering a lot of energy and almost 5 to 6 times more than Pakistan. So our Earth is offering finite system, and it's having limited resources, natural resources. And if we keep on using those resources the way we are doing, so how many Earths do we need to meet our and our future generations' lives? So more land would be needed to grow the food, to meet this food security, and more water resources would be needed to meet the water requirement, more land for urbanization, and sea level rise is obviously squeezing the land for urbanization, and more biodiversity and forests would be needed. be needed. So all of these areas cannot be availed from different planets. All of these things should be present on a single planet that we have here. So we don't have any alternative. We have to stay over here. We have to use these resources in a way that these resources would be available for the next generations, and we are not putting much effort in terms of protecting these resources. So we must stop this thing, and we must stop this kind of behavior and attitude, and we should look into the alternates. And having said that, we have only one planet. We have to make it sustainable. And then the challenge is obviously that we know it's another representation of the iceberg, that we see solid waste only, that this is the heap of a solid waste, but we don't think about the impact that can be generated, or that can be posed by this solid waste. And that can be seen over here, that solid waste is offering air pollution. It is conducting social unrest, poverty and slums, greenhouse gas emissions, water and wastewater depletion, and wastewater generation, and it's a non-sustainable development thing. So the waste management principles for sustainable cities say that there should be equity for all citizens to have access to waste management systems for public health reasons. ऐसा नहीं होना चाहिए कि किसी को मिल रही है सर्विस जो important है and the rest are not having the same quality of the service. Effectiveness of the waste management system to safely remove the waste. System must be robust enough to remove the waste timely, efficiency to maximize benefits, minimize costs, and optimize the use of resources. ऊपर हमारे पास performance थी, अब नीचे जो efficiency है, that is in terms of reducing the cost, जो waste management पे होती है, and maximize the benefits. So that would be depicting the input and output, and it would be related to the efficiency of the system. Then comes the sustainability of the system from a technical, environmental, social, and economic perspective. Financial, institutional, and political perspective may also be considered for the sustainability of the solid waste management system in a particular region. Waste to energy model or practices include the waste reduction, as we know that there is a 3R system, and it says that we must reduce, reuse, and recycle the waste, and the biogas generation comes under the category of the recycling, because the waste has been generated and now we are going to recycle that waste. Composting and biogas production with oxygen for agricultural fertilizers or fuel, anaerobic digestion, methane collected and combusted for energy. So this is a recycling opportunity, and that is we are like converting this waste to some product by the usage of some process and technique. So when process and technique comes into the system, then it becomes the recycling system. Reduction and reuse do not require any process. Landfill methane capture is another vital source for the capture of the landfill gases, as we discussed earlier in previous lecture. And incineration or the gasification from the combustible waste, burning of waste to reduce the volume of waste up to 90%. You know, the combustible waste, if incinerated, can be reduced to 90% lesser volume as compared to the original volume, and the remaining 10% would be the ash, and that is it won't be offering any hazard. Energy recovery models with waste streams with very high amounts of packaging materials, paper, cardboard, plastic, and horticultural waste are the constituents put, which are being incinerated. And burning without energy recovery is not recommended. incineration takes place at a very high temperature, and you need energy to incinerate. And if you are not going to recover the energy from the burning, then it won't be a sustainable or cost effective or economically feasible method, because to eliminate the waste, you are putting a lot of fossil fuel energy into the incinerator to burn the waste, and there is no recovery of the energy. So we must couple it with the recovery of energy. And the air pollution in terms of emissions from the incinerator, health problems from associated with the incinerator emissions must be taken care of, and there must be a specific design of the filters which must filter the gases effectively, so that the consequences like air pollution and health problems can be avoided. Coming back to our original topic, the biogas cycle, household waste and the livestock waste is put into the anaerobic digestion. Unlike the composting setup where we had aerobic system, here we have uh, to design a reactor which is sealed and airtight enough, and it should be offering anaerobic digestion. Then it would be resulting in the production of the biogas, which can be utilized in various like uh, areas. For example, we can power our vehicles with the same gas. We can generate electricity from that gas, and then later on, this electricity can be utilized to lighten up our homes. It The biogas can also provide the heat for the anaerobic digestion, which need elevated temperature to process further and to generate further biogas from the waste. What exactly is the biogas? It's a mixture of methane and carbon dioxide, and its properties are similar to the natural gas. And we have witnessed that the natural gas comes from the fossil fuels. So if both are in offering the same properties or characteristics, then natural gas can be replaced by the biogas. So there is a difference between natural gas and biogas. Biogas is the common name of the mixture of gases released from anaerobic digestion. The typical composition says that 50 to 70% is methane, carbon dioxide is 25 to 50%, hydrogen is 5 to 10%, nitrogen and H2S are also present as trace gases, and these can be purified to make the all the three gases like hydrogen, nitrogen, and hydrogen sulfide can be separated from the top two gases to make more pure biogas with high efficiency. Methane is the valuable part of the biogas that contains about 60 to 70% of methane, has a calorific value of about 6 kilowatt hour per cubic meters, what corresponds to about half an liter of diesel oil. So we can imagine that how much energy is associated in this biogas and how much energy it is offering to replace the diesel oil, which is coming from the fossil fuels. And it's a gaseous biofuel made up of a mixture of methane and carbon dioxide, and its biogas is not pure methane gas. It's not biodiesel, and similarly, it's not bioethanol as well. Remember, methane is dangerous, a very potent gas, greenhouse gas, and it has the global warming potential uh, of 23 as compared to the carbon dioxide, which is having global warming potential of 1. So it's 23 times much more potent as compared to the carbon dioxides. So you can imagine that if we are capturing the the methane and using it into a useful purpose, then it would be like uh, automatically reduction in the emission of the greenhouse gas into the atmosphere as well, because we are controlling the uh, gas generation and we are capturing the gas and then we are utilizing the gas into an effective manner. The process which is involved in the production of biogas is having some background, like anaerobic digestion is natural process which occurs when organic material is kept in absence of the air. So the organic material is transformed into the biogas, a renewable and green energy. In developed countries, this process has been evolved over the past 20 years, resulting in more and more complex large-scale biogas plants, including heating and multiple stage processes. So far, several million conventional biogas plants using predominantly animal manure as feedstock have been successfully installed in rural areas for developing countries, and anaerobic digestion as a controlled and voluntary process for the reduction and reuse of green waste has allowed to give answer to the soaring crisis of increasing municipal solid waste, for instance, in urban and peri-urban areas of developing world. And we can, in our case, in the case of Pakistan, we can add another value into the anaerobic digestion process, that we are having the energy crisis as well. So if the renewable energy approach is being adopted, then the energy crisis would be like being tackled or addressed to some level. In the anaerobic digestion process, microorganisms convert the complex organic matter to simpler molecules, that is the biogas. Some organic matter remains even after the digestion step, and this is called digestate or digested residue or the biofertilizer. Anaerobic digestion is used to treat the high strength wastewater. Now we know that we can introduce the leachate into the biogas reactor as well, because that's high strength wastewater. Organic solid waste, sewage sludge, black water, fecal sludge, agricultural waste, food industry waste, like breweries and slaughterhouses, dairy and manure. All of these waste or the sources of the waste can put their waste into the anaerobic digestion and convert it into a useful product with a lot of benefits. It can the anaerobic digestion with biogas production also occurs in landfills, septic tanks, natural or constructed wetlands, dams where vegetation was flooded. All these sites produce methane gas. So we come to know that anaerobic digestion is happening at its own to different sites. For example, landfill. We have put our waste into the landfill. We have covered from bottom and the top of the waste, and the thing has been made as anaerobic digester. Similarly, the septic tank is also uh, not having the that much quantity of oxygen, and the anaerobic conditions are dominant. Constructed wetlands, dams where the vegetation or the organic matter is present. All of these sites are offering different levels of anaerobic digestion and contributing to the production of the methane and emission into the atmosphere. तो उससे आप अंदाजा लगा लें कि this is happening naturally into different sites which are being mismanaged. तो अगर इसको हम मैनेज करके इस वेस्ट को उधर जाने ही ना दें, एंड हम इसको खुद से ही ये सारी इंडस्ट्रीज का डोमेस्टिक और इसी तरह से वेस्ट वाटर ट्रीटमेंट प्लांट से आने वाला, डोमेस्टिक वेस्ट वाटर से आने वाला, मतलब आपके पास देयर आर ए लॉट ऑफ कैटेगरीज ऑफ वेस्ट व्हिच कैन बी एड्रेस्ड एंड यूज्ड इन दिस बायोगैस जनरेशन सेटअप. तो हमारे लिए ये बहुत attractive opportunity, and we fortunately we are having the same range of the temperatures, atmospheric temperature, which are needed for the biogas production. So Pakistan is a very feasible country in terms of the production of the biogas. This is the basic flow chart in which we can see that these are the influents. Can you see the cursor? Please confirm.
Yes, sir.
These are the organics which are being fed to this digester. And this can be the cow dung material, which is having all these things into it. And then it is being sent to the anaerobic digester, where it takes some times and the products are like methane, carbon dioxide, and trace gases. These are collected for the effective utilization. The rest of the waste is collected for the biofertilizer, and then what comes out of the system is ammonium, organic nitrogen, phosphorus, and potassium. So the same thing which was sent into the system is being collected, but with simpler molecules, stable molecules. हम काउ डंग मटेरियल को डायरेक्टली अगर वहां पे डंप करते हैं अपनी फील्ड्स में तो वहां पे प्रॉब्लम होता है, और जो डाइजेस्टर में टाइम लगना था, प्रोसेस लगना था, वो वहां पे भी उसको चाहिए होता है। एंड एटमॉस्फेयर में ऑक्सीजन भी है, तो इट कैन नॉट बी लाइक ऑपरेटेड इन द सेम वे। सो जब आपने डाइजेस्टर में इसको कन्वर्ट कर लिया तो गैस आपने कलेक्ट कर ली, वहां से तो गैस भी कलेक्ट नहीं कर पाएंगे अगर फील्ड्स में फैला देंगे तो। अच्छा, यहाँ पे आपने गैस भी कलेक्ट कर ली और जो रिमेनिंग पार्ट था उसमें सेम आपने उसके जो कॉन्स्टिट्यूएंट्स थे वो सेम कॉन्स्टिट्यूएंट्स ले लिए, बट क्या है कि आपको सिंपलर स्टेबल मॉलिक्यूल्स मिल रहे हैं विच कैन बी यूटिलाइज्ड एज फर्टिलाइजर फॉर द सॉइल फर्टिलिटी। This is another elaboration of the process. This process is showing the happens inside the reactor. There are two phases. The first phase is acid forming bacteria and the second phase is the methane forming bacteria. तो जो हमारे पास एसिड फर्स्ट फेज है उसमें लिक्विफिकेशन होती है और सेकंड फेज में गैसिफिकेशन होती है। फर्स्ट फेज में जो बैक्टीरिया उनको एसिडोजेनिक बैक्टीरिया कहेंगे और मिथेनोजेनिक बैक्टीरिया आर इन सेकंड फेज। Then degradability of organic materials can be like depicted from this chart, जिसमें हमें आइडिया होता है कि कौन सी चीज बहुत ज्यादा बायोडिग्रेडेबल है और कौन सी चीज बहुत कम बायोडिग्रेडेबल है। तो हम बायो कंपोस्टिंग की तरह यहाँ पे भी रिएक्टर में अपने डिजायरेबल वेस्ट को जो है वो हम यहाँ पे इनकॉर्पोरेट कर सकते हैं। सो शुगर, वेजिटेबल्स, fat, faces are offering easy degradation as compared to the wood chips. यहाँ पे हमारे पास बायोगैस की प्रोडक्शन की एफिशिएंसी या यील्ड है कि किससे कितनी जो एफिशिएंसी है वो अचीव हो सकती है। वी कैन सी दैट liquids and grass and animal manure is offering more and more production of methane content. These are the basic terminologies. Anaerobic is in the absence of oxygen, aerobic in the presence of oxygen. Anaerobic digestion is the reactor, which is a process which is breaking down or decomposing the waste in organic material in the absence of oxygen. Digestate is the effluent from a digester, the liquid product of the anaerobic digestion process. Biogas is the gas produced by the microorganism in anaerobic process. Biogas digester or the reactor is the vessel or designed unit which is offering this, which is hosting this process. Green waste, we have already discussed the types of the waste in our initial lectures, and the green waste is coming from the garden refuses, market waste, refuses from the food industry, waste from the agriculture, organic fraction of municipal solid waste, some industrial waste are also offering the organic or the green waste, and kitchen refuse also comes under the category of green waste. Anaerobic digestion of green waste says that you have to put the green waste into the anaerobic digestion and it would be converting it into the gas which can be used for the cooking, lighting, heating, electricity generation, and fuel. While the solid component is collected as the biofertilizer and can be used for the agricultural activity. So it's a very simple thing. The basic thing, we need to choose the right material and we have to optimize the anaerobic digestion. Then we have to look into the uses which can be adopted for the biogas. So this is the cycle for the biogas process. And if we have selected some material and we have to put into the reactor, then we have to obviously grind it. Digestion takes place, then dehydration will start because the dehydration would be leading to the production or generation of the gas, and sludge would be treated. So these are the usage. Again, these are the usage of the produced gas. All of these flow charts are shared with you for complete and deep understanding. The anaerobic digestion, previously we had two phases, but both of the phases are offering two further stages. So we have total 4 stages in an anaerobic digestion unit. The first stage is hydrolysis, cleavage of a chemical compound through the reaction with water. It's like the आप कह लें कि जो decomposition start होने के लिए जो basic आपका process start होता है, that is hydrolysis, क्योंकि आप पहले water को उसमें introduce करवाएंगे तो moisture content would be playing the vital role. जैसे हमने कंपोस्टिंग में कहा कि पोर्स में ऑक्सीजन होती है तो मॉइस्चर कंटेंट बढ़ जाएगा तो एनारोबिक कंडीशन बन जाएगी. तो यहाँ पे हम मॉइस्चर कंटेंट ज्यादा करते हैं इंटेंशनली because water will be solving all the organic matter into it, and the higher moisture content would be making it easy for the generation of the anaerobic conditions, and the anaerobic bacteria would be coming into the action and playing their role for the breakdown of the chemical compounds. And the basic breakdown of the chemical compounds is called as hydrolysis. Insoluble complex molecules are broken down to short sugars, fatty acids, and amino acids. So complex organic molecules are converted into these molecules. Then comes the stage which is being carried out by acidogenesis bacteria, and it is called as fermentation. Products from hydrolysis, अब जो पिछली प्रोडक्ट्स थी जो हमारे पास शुगर है, फैटी एसिड है, अमीनो एसिड है, those are transformed into organic acids. अब उनको एसिड्स में कन्वर्ट किया जा रहा है. अल्कोहल्स, कार्बन डाइऑक्साइड, हाइड्रोजन एंड अमोनिया. अभी तक मीथेन नहीं बनी, कार्बन डाइऑक्साइड बन गई है. Then comes the acetogenesis. Acetogenesis itself is organic acids and alcohols are converted into hydrogen, कार्बन डाइऑक्साइड एंड एसिटिक एसिड. एसिटिक एसिड की वजह से एसिटोजेनेसिस भी इसको कहा जाता है, बिकॉज एसिटिक एसिड की ऊपर हमारे पास एसिड्स तो आ रहे थे, बट दोज वर लाइक फैटी एसिड्स और द मिक्सचर ऑफ सम अदर ऑर्गेनिक एसिड्स. लेकिन एसिटिक एसिड जो है उसकी प्रोडक्शन इसलिए जरूरी है कि CH4 जो है वो एसिटिक एसिड से ही फर्दर आगे बननी थी. So methanogenesis is the last stage, which is methanogenic bacteria is responsible for the methanogenesis, and it transforms the acetic acid, carbon dioxide, and hydrogen into biogas. Biogas means CH4 plus carbon dioxide. हाइड्रोजन जब मिलेगी इसके साथ एसिटिक एसिड के साथ तो ये CH4 बनाएगी, उसके साथ कार्बन डाइऑक्साइड निकलेगी और एक और हाइड्रोजन जो है वो लास्ट हाइड्रोजन मॉलिक्यूल के साथ मिलके हाइड्रोजन मॉलिक्यूल बनाएगा जो कि ट्रेस अमाउंट में होगी. So the dominant part would be coming from this part of the acetic acid, then there would be carbon dioxide, then an other addition of hydrogen atom into the previously released hydrogen atom would be resulting in the formation of hydrogen gas, which is in trace amount. This is the elaboration of all 4 stages through the flow chart. यहाँ पे आपने carbohydrates या अपना complex organic material जो है उसको हाई वाटर कंटेंट में रखा और उसमें जो है वो आपके प्रोटीन्स एंड फैट्स बने. प्रोटीन से फर्दर जो सिंपलर मॉलिक्यूल्स अमीनो एसिड्स बनते हैं और फैट से फैटी एसिड्स बनते हैं. And this is the transition stage that fermentation takes place and organic acid, alcohol, hydrogen, carbon dioxide और अमोनिया बनती है. Then comes the acetogenesis जिसमें हमारे पास acetic acid and finally methanogenesis results in the production of the CH4 and CO2. एनारोबिक डाइजेस्टर का मैंने आपको कुछ बताया. हम इसकी कुछ करेक्टरिस्टिक्स देख लेते हैं सो दैट यू आर क्लियर्ड इनफ. वैसे तो हमें बाकी टर्मिनोलॉजीज और बाकी सारी चीज़ों का पता होता है बट स्टिल एज एन इंजीनियर यू मस्ट नो द बेसिक functions of the and the digester first while it is being utilized as the decomposition unit. Airtight chamber होता है इसका, filled with the green waste. Anaerobic digestion takes place. Sludge settles on the bottom. Gas bubbles up to the top where it is collected. Reaction temperature which is needed inside the reactor is 35 to 55 Celsius. Mesophilic and thermophilic range of the bacteria like in composting is active here. इसमें साइक्रोफिलिक नहीं है because they are having lower range of the temperature. Either continuous or in batch mode. जब आपके पास वेस्ट है तो आप उसको बैच सिस्टम में भी चला सकते हैं, कॉन्टिन्यूस सिस्टम भी बना सकते हैं. बैच होगा तो क्या होगा, filled and left for digestion after the hydraulic retention time, emptied and filled again for a new cycle. आप एक बैच को इंट्रोड्यूस करवाते हैं, उससे बायोगैस जनरेट होती है, बायो फर्टिलाइजर सेपरेट कर लेते हैं और फिर से नया बैच शुरू कर देते हैं. कॉन्टिन्यूसली स्टिर टैंक रिएक्टर CSTR says that continuous in and outflow and mixing takes place. Plug flow reactor is the sludge moves through the reactor much like a train to the tunnel which is with a velocity corresponding to the minimal HRT. इसमें क्या होता है कि आपका एक बैच जो है वो ट्रीट होके निकल रहा होता है, मीनवाइल आपका सेकंड बैच जो है वो इनसाइड द रिएक्टर रेडी होता है. द लिक्विड फेज कैन बी रीसर्कुलेटेड टू मेंटेन ऑप्टिमल मॉइस्चर कंडीशंस. These are the small scale biodigesters which can be utilized to the domestic levels. Here we can see a portable reactor from the Indian NGO Biotech startup which is moving into the community and collecting the organic waste to put into this reactor and generating the gas. These are the large scale biodigester examples which are situated in different areas of the world. These are the appliances which are needed for the biogas processes. Again, how the organic waste is converted into the electricity or the other useful purposes. Process parameters क्या हैं और उनमें किस चीज का ख्याल रखना है हमने. Biogas yield depends on the process and substrate. Substrate means high COD इसमें चाहिए आपको. लो COD या लेस ऑर्गेनिक मटेरियल से एनारोबिक डाइजेशन इफेक्टिव नहीं होगी. बायोगैस ज्यादा जनरेट करने के लिए हाई कंटेंट चाहिए. इट्स लाइक कि आप डोमेस्टिक वेस्ट वाटर जो है उसमें से COD देख रहे थे तो वो कम थी और लीचेट में बहुत ज्यादा थी, तो लीचेट यहाँ पे काम आएगा आपके, हाई COD होगी उसके अंदर. Anaerobic digestion में biological system of bacteria होता है. Optimal conditions are required that bacteria feel wealthy for the decomposition. Temperature उसकी performance और retention time को affect करता है. अगर साइक्रोफिलिक रेंज में ले जाएंगे तो परफॉर्म नहीं कर पाएगा, रिटेन नहीं कर पाएगा. pH varies 6.5 to 7.5. How pH can impact the performance of the bacteria. Total solids and moisture should also be taken into the account. Wet digestion takes place with less than 20% total solids, and um, dry digestion takes place with a higher quantity of the total solids. This is another commercial biogas plant which is developed in 2003, and you can see that the appropriate Rural Technology Institute has developed a 2,000 plants used in India, Maharashtra. Similarly, with different configurations, the gas is being generated. They have used the floating drum digestion, like the drum is floating when the gas is generating. This drum is not offering that much weight, and the indication of the generation is taken from the floating drum. जब वो फ्लोट करने लग जाता है तो इसका मतलब है कि नीचे गैस जनरेट हो चुकी है. इसी तरह से बायोटेक प्लांट है, इसमें भी आप जो है वो उसको गैस को जनरेट कर रहे हैं. हाउस होल्ड लेवल पे आप अप्लाई कर सकते हैं, कम्युनिटी लेवल पे, इंस्टीट्यूशनल लेवल पे, जहाँ जहाँ पे आपकी पॉसिबिलिटी है. उन कॉन्टिन्यूसली वेस्ट आ रहा है तो वेस्ट की आप जो डिस्पोजल है उसको भी अवॉइड कर रहे हैं और यूजफुल प्रोडक्ट भी बना रहे हैं. और अगर डिफरेंट लेवल्स पे अगर हम इसको यूटिलाइज करते हैं, दैट मीन्स कि हम उन डिफरेंट लेवल्स पे जो हमें फॉसिल फ्यूल से आने वाली एनर्जी चाहिए थी उसको हमने वाइप आउट कर दिया है. So waste to wealth is a big opportunity in case of adopting the biogas production. It can be converted into the business. You can have your own modified patent of the process and the technology. You can come up with an idea which can be like commercialized, and then you would be like offering your services to different institutions, communities, and household levels who are interested in buying your technology and who are interested in having you as consultant for the optimization of their anaerobic digestion process, and who are interested in having you as consultant for the selection of the best material for the production of gas. They can hire you or consult you in terms of increasing the efficiency of the process and effective utilization into after the production of the gas. So quality parameters and quality measurement is a missing thing. These are the weaknesses. Value of the certificates is missing thing. Injection into the grid system is also under consideration and still being investigated, that अगर हम biogas बहुत ज़्यादा बना लेते हैं तो how it can be coupled with the national grid. So this is how the top 10 NGV countries in the world based on the total NGVs. Fueling stations. So this is a study which is comparing Italy and Pakistan. Just to realize that how much biogas is needed and how it can be utilized. So this is the output from a biogas digester, and you can check with the flame that whether the biogas is generated or not. Similarly, you can check the quality of the flame, that whether it would be effective for the utilization or not. Like it would be having or offering the required calorific value, or it is not offering the same calorific value. The uses have already been discussed. Local benefits includes reduction in odor, fly eggs, weeds, seeds, indigested manure, revenues, on-farm power production sales, tipping fees from other feed stocks would be reduced. रीजनल लेवल पे क्या बेनिफिट्स हैं? पैथोजेंस की रिडक्शन है, रूरल इलेक्ट्रिक ग्रिड वोल्टेज सपोर्ट मिल जाती है, लोग जो है वो अपनी इलेक्ट्रिसिटी कम यूज कर रहे हैं। ग्लोबल लेवल पे मीथेन एमिशंस एंड ग्रीन हाउस गैस की एमिशन जो है वो रिड्यूस हो जाएगी। रिड्यूस डिपेंडेंसी ऑन फॉरेन फॉसिल फ्यूल्स। हमारे केस में, पाकिस्तान के केस में तो सारा इंपोर्ट हो रहा है, तो फॉसिल फ्यूल जो फॉरेन हम इंपोर्ट कर रहे हैं, ऑयल एंड गैस एंड सिमिलरली अदर फॉसिल फ्यूल एनर्जी सोर्सेस, कोल वगैरह, तो उसमें हमारे पास जो है वो डिपेंडेंसी खत्म हो जाती है। इसके अलावा इसको हम कैटेगराइज कर सकते हैं सोशल, इकोनॉमिक एंड एनवायरमेंटल बेनिफिट्स। सोशल बेनिफिट्स में जॉब क्रिएशन है। जब आप बिजनेस स्टार्ट करते हैं तो ऑब्वियसली you would be needing someone to fabricate your reactors. You would be needing someone to provide you with the pumps and pipes and stove and other related appliances. तो उसमें आप जॉब क्रिएशन क्रिएट जो है वो रोल प्ले कर रहे हैं। इसी तरह से आपको मार्केटिंग का बंदा चाहिए हो सकता है, आपको डिजाइनिंग का बंदा चाहिए, प्रोसेस का बंदा चाहिए, ट्रांसफॉर्मेशन का। तो आप जॉब क्रिएशन बेसिकली एक नया यूनिट जो है वो ऐड कर रहे हैं। हेल्थ इंप्रूवमेंट सोशल बेनिफिट है कि वेस्ट जो है वो कम से कम जाएगा आपकी लैंडफिल में, तो हेल्थ इंप्रूवमेंट होगी, लाइफस्टाइल इंप्रूवमेंट होगी, आपका एस्थेटिक्स बेहतर होगी। इकोनॉमिक बेनिफिट्स में एनर्जी सेविंग आपकी होना शुरू हो जाती है, फार्म डेवलपमेंट कर सकते हैं, वेरियस यूज ऑफ एंड प्रोडक्ट कैन बी यूटिलाइज्ड एज इकोनॉमिक बेनिफिट। एडवांटेजेस जो है वो इसके जैसे जनरेशन ऑफ बायोगैस है, जिसमें एनपी के रेशो का ख्याल रखा जाता है, रिडक्शन ऑफ ग्रीन हाउस गैस है, कंबाइंड ट्रीटमेंट ऑफ डिफरेंट ऑर्गेनिक वेस्ट एंड वेस्ट वाटर है, रिडक्शन ऑफ सॉलिड टू हैंडल्ड द स्लज है, good pathogen removal depending on temperature, process stability, and disadvantages include small to medium scale anaerobic technology for the treatment of solid waste in middle and low income countries is still relatively new. अच्छा, हमारे पास जो है वो बिल्कुल ही पायलट स्केल या बेंच स्केल रिएक्टर्स हैं। स्मॉल स्केल या मिडिल स्केल एनारोबिक टेक्नोलॉजी अभी हम डेवलप नहीं कर सके। लाइक थोड़ा सा बड़ा बायोगैस प्लांट हम सक्सेसफुली नहीं चला सके। Experts are required for the design and construction depending on scale, may also for operation and maintenance. तो ऑपरेशन, मेंटेनेंस, डिजाइनिंग, कंस्ट्रक्शन, इस सारी चीजों के लिए एक्सपर्ट्स चाहिए आपको। रीयूज वो आप खुद हैं एक्सपर्ट्स। रीयूज ऑफ प्रोड्यूस्ड एनर्जी, ट्रांसफॉर्मेशन इनटू द डिफरेंट यूजफुल पर्पसेस, हाई सेंसिटिविटी ऑफ मिथेनोजेनिक बैक्टीरिया टू अ लार्ज नंबर ऑफ केमिकल कंपाउंड्स, सल्फरस कंपाउंड्स कैन लीड टू ओडोर। H2S जो है उसकी वजह से ओडोर आ सकती है, उसको कैप्चर करने का मैकेनिज्म बनाएं। Aerobic digestion of green waste, again all these things have been discussed. This is the mechanized or under control process of the organic waste. They have segregated all the organic waste from the other categories of the waste. Now they have shredded it and adding moisture or the additives for the production of the biogas. यहाँ से इसको फिर वो feed करेंगे to the main reactor, और उसमें फिर जो है वो इसको जो है बायोगैस जनरेशन के लिए कुछ टाइम के लिए छोड़ेंगे। तो आप देखो ये कॉन्टिन्यूसली फीड जो है वो उनके पास अवेलेबल है। कॉन्टिन्यूसली जब फीड अवेलेबल है तो इसको फिर फर्दर बायोगैस में कन्वर्ट करेंगे, फर्टिलाइजर में कन्वर्ट करेंगे, तो कितना यूजफुल प्रोडक्ट जो है दैट वुड बी अचीव्ड एंड the waste, this much quantity of the waste on daily basis would be handled and eliminated from the environment, और environmental harm जो है वो भी हमारा threat खत्म हो जाएगा। ये स्मॉल स्केल पे जो है वो इसकी मेसनरी स्ट्रक्चर भी आप बना सकते हैं, इस तरह का मैकेनाइज स्ट्रक्चर भी बना सकते हैं जिसमें फ्लोटिंग ड्रम है जो जैसे जैसे इनिशियली इसका ये वाला लेवल जो है वो यहाँ पे होता है विद द प्रोडक्शन ऑफ द गैस, आपको ये बता देता है। तो ये इसको एक इंडिकेटर के तौर पे भी यूज कर सकते हैं कि ज्यादा गैस जनरेट हो रही है या कम गैस जनरेट हो रही है। यहाँ से आप फीड स्टॉक जो है वो इसके अंदर ऐड करते हैं, ये यहाँ नीचे जाता है। इसी तरह से आप जो है इसकी स्लरी जो है उसको निकाल लेते हैं। तो इट्स अ वेरी इंटरेस्टिंग फैक्ट दैट कि आप इससे बायोगैस जनरेट करते हैं और उसको कलेक्ट कर लेते हैं। ये आपको इट्स अनदर टेक्नोलॉजी और मे बी इनोवेशन के इसमें आपको जो कवर है वही बता देता है कि इसमें बायोगैस जनरेट हुई है या नहीं। तो ये कवर जो है बेसिकली गैस के फिल होने से जो है वो बलून की तरह जो है वो हो जाता है और उसमें आपको थोड़ा सा आइडिया हो जाता है कि गैस की क्वांटिटी सफिशिएंट है या नहीं। These can be the related facilities for the biogas generation plant. These can be the equipment needed for the biogas generation plant on larger scale. This can be done in the laboratory as well, where you can have this bottle as a very good anaerobic digester. इसको आप एयर टाइट करें और इसके अंदर जो है वो गैस जनरेट हो जाएगी। ठीक है, इस गैस को जनरेट होगी तो इसको आप कैप्चर कर सकते हैं टू अ वेरी सिंपलर यूनिट। और इस ट्यूब को फिल होने के बाद आप द क्वांटिटी ऑफ द गैस कैन बी लाइक मेजर्ड, ये आपने कैप्चर कर ली है। इसी तरह से जो है वो आपको जो बायोगैस है जो उसकी प्रोडक्शन के बाद आपको इसमें जो क्या कहते हैं फर्टिलाइजर है उसको भी आप यूटिलाइज कर सकते हैं। और यू कैन ग्रो प्लांट्स फॉर द एप्लीकेशन ऑफ द फर्टिलाइजर एंड यू कैन check the what should I say, you can check the performance of the फर्टिलाइजर। आप एक प्लांट में जो है वो फर्टिलाइजर अप्लाई कर रहे हैं, एक प्लांट में वो वाली नहीं कर रहे हैं, उसको सिंपल रख रहे हैं, एक प्लांट में आप केमिकल फर्टिलाइजर यूज कर रहे हैं। तो देयर कैन बी अ सेट ऑफ द प्लांट्स, तो उसके ऊपर भी आपकी कंपैरिजन जो है वो हो सकता है। इफ यू आर इंटरेस्टेड तो वी कैन कंडक्ट दिस एज ए प्रोजेक्ट एंड इसके लिए हम जो है वो डिफरेंट स्पॉन्सर्स या डोनर्स को भी कांटेक्ट कर सकते हैं दैट वी आर गोइंग टू स्टार्ट विद दिस एंड वी वुड बी एंडिंग अप इनटू द biogas production to at least the university level space. Wow. Wow. So we are done with the lecture. This is the end of the lecture. I was not expecting, by the way. So we have covered the biogas topic as well. I believe that you have understood all the basic things I discussed. I would like to recall all the things in terms of making it more valuable lecture for you. We started up with the recalling of the basic functional elements of the waste management. One of the category which comes under the processing and recovery is the biogas generation, and we started up with the need, setting up the stage for the need of the biogas generation. So we came to know that there is a lot of energy consumption in the world, and there is a dire need to look into the different energy sources. And then we compared the Pakistan with the other countries in terms of the energy provision. Then we came up to know that there are very less chances of having another planet. Then we came to the challenge that it's not the solid waste, but the associated threats as well. Then the basic terminologies of the waste and the conversion of the biogas waste into the biogas. We came into the system by knowing the different like reactor design and the stages involved in a reactor and the uh, phases involved in a reactor. And then we moved up to the household level, small level, community level, and other levels of the digestion processes. And then we discussed the basics of the advantages and disadvantages of the biogas generation. Here we had yield and basic terminologies related to the biogas and benefits of the biogas and usages of the biogas, basically. These are the 4 stages which are involved: hydrolysis, fermentation, acetogenesis, and methanogenesis. Hydrolysis involved water addition. Fermentation involves the anaerobic digestion of the organic waste into the carbon dioxide, alcohols, and organic acids. आपको पता है fermentation से alcohol बनती है. Then acetogenesis में acid formation है और वो भी acetic acid. जैसा कि इसके नाम से ही पता चल रहा है. Methanogenesis is involving methanogenic genesis bacteria and producing the biogas. बायोडाइजेस्टर क्या है, दुनिया में क्या हो रहा है, कहाँ पे अक्रॉस द ग्लोब जो है वो, इसके प्रोसेसेस क्या हैं, उसके पैरामीटर्स क्या हैं, डिफरेंट लेवल पे किस तरह से इसकी प्रोडक्शन हो रही है और इसकी एप्लीकेबिलिटी कहाँ पे है, कहाँ कहाँ पे गैप्स हैं, यूसेजेस इसके क्या हैं, इसके बेनिफिट्स सोशल क्या हैं, इकोनॉमिक क्या हैं और एनवायरमेंटल बेनिफिट्स एज डिस्कस्ड अर्लियर. तो ये हमारे पास था बायोगैस का सारा हमारा कंप्लीट जो है वो सिस्टम. एंड देन वी केम अप विद एन आइडिया कि इफ you are going to have a hands-on experience of this technique, तो आपके पास like you can have this project as well. So this was all about the biogas. If you have any questions, please ask so that we can conclude this session. Yes,
No,
please.
sir.
या तो सारा समझ आ गया या बिल्कुल समझ नहीं आया. But still, if you have questions, and I'm very happy to see almost 23 attendees, including me. तो रेगुलर क्लास में आप लोग इतना नहीं आते जितना ऑनलाइन क्लास में आ गए. I believe सारे present हैं. Let me check with the
Yes,
attendance. Adil, are you there? Hurry up, please. Adil. Alina.
प्रेजेंट सर.
Arfa.
जी सर इधर ही हूँ.
Babar. Fatima. Babar is not
जी सर,
here. Like
present. जी सर.
Anzila. Hasib.
Yes, sir. Present. Present, sir. Present, sir.
Janice.
Present, sir.
Faiz Zawar. Kipsha.
Present, sir.
Laiba.
प्रेजेंट
Manzar.
सर.
Manzar. Mariam.
Present, sir.
सर.
Muhammad Abu
सर
Bakr.
मैं प्रेजेंट हूँ.
All right. Abu Bakr. Awais. Muzammil. Nimra.
Present, sir.
Rana Jahan. Zeb.
Present, sir.
Siptan. सिद्रा.
Present, sir.
4-5 लड़के जो क्लास में नहीं आते वही भाई. एनीवेज रिकॉर्डेड सेशन भी
Sir,
अवेलेबल
roll number-
होगा. If you,
Sir.
Kareem is also there. Wow, nice.
Sir, I am also present.
Yeah, listen. So do we have much more candidates? Umas? Umas is there.
Yes, sir, present.
Okay. Any questions?
असलम सर आई वाज प्रेजेंट जब आपने जवार का नाम लिया था फिर लाइट चली गई थी 1 मिनट के लिए डिस्कनेक्ट हो गया था।
वालेकुम अस्सलाम। मुझे तो लगता है भाई आप दही लेने गए थे और आप वापस आ गए हैं, किसी ने मैसेज कर दिया।
नहीं सर, नहीं
अच्छा।
किसी ने मैसेज नहीं किया सर। जवार का जब आपने नाम लिया तब मैं था लास्ट उस पर
ओके
डिस्कनेक्ट हो गया।
ओके यार, अगर आए हो बैठे रहे हो तब भी आपका फायदा है। अगर नहीं आए और कोई नहीं आया, आपको नहीं कह रहा, कोई नहीं आया और यहाँ पे एनरोल करके चला गया और उसने नहीं लिया लेक्चर, तो तब भी उसका फायदा है। मतलब he must have put his time to some valuable thing ना, मतलब ये वैल्यूएबल नहीं होगा उसके लिए एट द मोमेंट। इससे किसी अच्छी एक्टिविटी में इन्वॉल्व होगा तो तभी इसको छोड़ो। So it's all about your priorities, no regrets at all. किसी का कोई क्वेश्चन है तो काइंडली वो शेयर करें सो दैट वी मे एंड अप द सेशन। ऐसा ना हो कि मुझे एक और क्लास रखनी पड़े ऑनलाइन और आप उसमें भाग जाएं कि सर तो छोड़ते नहीं है फिर। I'm sensing maybe we would be able to conclude the disposal session in our upcoming live class. और उसके बाद मुझे चाहिए होगा कुछ आपका cooperation in terms of having another session which would be a very brief and short session to discuss the hospital waste and electronic waste. I don't want to miss those things because those are the vital components of the waste management system. So that can be done in an online session anytime in the evening.
ओके सर।
So Umesh, please
Okay,
set
sir.
up the time. किसी भी दिन मुझे बताएं आप, तो we would be having that session to discuss the hospital waste management systems and the electronic waste management.
ठीक है सर, मैं बता दूँ।
Okay, thank you very much for your time. I would be sharing this video